All right, so get this, we're diving deep today into NVIDIA's Ampere GA102 GPU architecture. This is the tech behind not just the RTX 3090 and 3080, but also the professional grade cards. Like the RTX A6000 and the A40, we're going to peel back the layers of this chip and really get to grips with how it's changing the game for everything from 8K gaming to AI-driven graphics.
Well, one thing that's really striking about the GA102
Mm-hmm.
is the sheer density of the design. We're talking 28.3 billion transistors squeezed onto a 628.4 millimeter 2-die die. To give you some perspective, that's like cramming the entire population of Texas onto a postage stamp.
Okay, so that's a lot of transistors. But what does that mean for performance? It can't just be about fitting more components onto a chip, right?
Right, it's about how all of these components work together. The GA102 is built around three key processing units: CODA cores, which handle traditional rendering, RT cores for real-time ray tracing, and tensor cores for AI workloads. Each of these units has been significantly enhanced in Ampere.
Okay, let's break those down a little bit further. I've heard a lot about this 2x FP2 processing in Ampere. What's so special about that?
So essentially, NVIDIA doubled the rate at which the GA102 can process FP32 operations. These are the most common type of calculations used in graphics rendering. Compared to the previous Turing architecture, this is a massive leap forward. It means that games can render smoother, professionals can work faster, and scientific simulations can be run more efficiently.
So is it really like having two GPUs in one, like some people have been saying?
It's not quite that simple, but the performance gains are significant. One of the key factors here is the redesigned streaming multiprocessor, or SM. The GA10X SM has a larger L1 cache and increased bandwidth, which allows it to access and process data more efficiently.
So it's like giving the GPU a bigger and faster workspace to handle all those complex calculations.
Exactly, and this improved data flow within the SM is crucial for everything from traditional rendering to the more specialized tasks handled by the R2 tensor cores.
Okay, well, let's talk about those specialized tasks then, starting with ray tracing. NVIDIA has been touting ray tracing as a game changer for a while now, but what's different with Ampere?
So Ampere features second-generation RT cores, which are twice as fast as the ones found in Turing. This means that they can render those incredibly realistic reflections, shadows and lighting effects even faster. But the real innovation lies in Ampere's ability to perform concurrent RT and shading.
Concurrent RT and shading, that sounds intense. What does that even mean?
So it means that the GA102 can handle both ray tracing and traditional rasterization at the same time, without any impact on performance. Previous architectures had to switch back and forth between these tasks, which created a bottleneck. Ampere eliminates that bottleneck, which paves the way for even more complex and realistic visuals.
So games can now have both the detailed lighting of ray tracing and the smooth performance of traditional rendering. That sounds like a win-win to me. But wait, there's more, right? Something about motion blur being improved as well.
Yes, Ampere also introduces ray trace motion blur, which is another feature, accelerated by the dedicated hardware in those second-generation RT cores. What this means is that moving objects can have realistic motion blur applied to them in real time, which adds another layer of visual fidelity to games and other applications.
Okay, I can definitely see how that would make action scenes or fast-paced games look incredible. Now let's talk AI. What advancements have been made with the tensor cores in Ampere?
Well, third-generation tensor cores in Ampere are designed for both power and efficiency. They've introduced a feature called sparsity, which allows them to basically skip over unnecessary calculations. When working with certain AI models, this can actually double the performance of these cores in specific AI workloads.
That sounds interesting, but I'm having a little trouble wrapping my head around how that translates into things that I would actually see or experience.
Take DLSS 8K, for example. This is an AI-powered upscaling technology that uses tensor cores to render games at a lower resolution and then intelligently upscale them to 8K. The sparsity feature makes this process much faster and more efficient, which allows gamers to experience incredibly detailed visuals without needing a supercomputer to run them.
8K gaming powered by AI, that's pretty wild, but it sounds like these tensor cores are good for more than just gaming, right?
Absolutely. Another great example is AI-powered denoising. So in real time, Ampere can use its tensor cores to identify and remove noise from rendered images, resulting in smoother and more visually pleasing results in games and professional applications.
So it's like having a built-in noise filter for your graphics. That's pretty impressive, but all this processing power needs data and a lot of it. How does Ampere keep up with the demand?
That's where GDDR6 memory comes in. This is next-generation memory technology that uses innovative signaling techniques to achieve significantly faster data transfer rates than previous generations. We're talking about up to 936 GBs of bandwidth in the GeForce RTX 3090.
Okay, hold on. 936 gigabits per second. Just how much faster is that? Compared to older memory technologies, what kind of bottleneck does that solve?
It's a massive leap forward. To put it into perspective, GDDR6, the previous generation, topped out at around 600 gigabytes per second. This boost in bandwidth means the GPU can access and process the massive amounts of data required for things like 8K gaming and real-time ray tracing without being held back by the memory.
So it's like they've upgraded the data highway to handle all that traffic. No more traffic jams for the GPU.
Exactly, and this is crucial for modern games and applications that are becoming increasingly demanding in terms of data throughput. But there's another bottleneck that NVIDIA is addressing with Ampere, and that's the way that games are loaded and streamed from storage.
Yeah, I've definitely noticed that games are getting huge, but loading times haven't really kept up. Does Ampere have a solution for that?
They do. It's called RTX I/O. This technology essentially allows the GPU to directly access and decompress game data from NVMe SSDs, bypassing the CPU, which was previously a major bottleneck in the process.
So instead of the CPU acting as a middleman, the GPU can just grab what it needs directly from the SSD. That's got to be way faster, right?
We're talking about potential speed increases of up to 100x. Compared to traditional loading methods, it could revolutionize the way we experience open-world games and other applications that rely on streaming large amounts of data. Imagine jumping into a massive game world in the blink of an eye with no loading screens or delays.
Okay, you're really selling me on this RTX I/O thing. It sounds like a game changer, literally. But we've been talking a lot about gaming. What about the professional applications of Ampere? Didn't you mention something about the A40 and RTX A6000 being designed for data centers and workstations?
Absolutely. While the gaming-focused features of Ampere are impressive, the A40 and A6000 bring that same level of innovation to the professional world. We're talking about GPUs designed for tasks like rendering complex 3D models, running scientific simulations, and training massive AI models.
So these are the workhorses. For professionals who need serious processing power.
Exactly. And they come with features specifically tailored to those demanding workloads. For example, both the A40 and the A6000 boast a massive 48 gigabyte of GDDR6 memory, which is essential for handling the huge data sets common in professional applications.
48 gigabytes? That's more memory than most entire computers have. What could you possibly need that much memory for?
Think about rendering a detailed 3D model of an entire city, or simulating the interactions of millions of particles. These tasks require storing vast amounts of data in the GPU's memory for quick access. And if that's not enough, you can even link two A40 or A6000 GPUs together using NVLink to create a colossal 96 gigabyte memory pool.
Wow, that's some serious firepower. But beyond memory, what else makes these GPUs stand out for professionals?
Well, reliability and stability are paramount in professional environments, and these GPUs are built to deliver just that. They undergo rigorous testing and certification processes to ensure they can handle demanding workloads without crashing or experiencing errors.
So it's not just about raw performance, but also about making sure that these GPUs can be relied on to get the job done without any hiccups.
Exactly. And let's not forget about software support. NVIDIA provides specialized drivers and software tools that are tailored to professional applications, ensuring optimal performance and seamless integration into existing workflows.
It sounds like NVIDIA has really thought of everything when it comes to the needs of professionals.
They strive to, and they're constantly innovating to address the evolving challenges faced by professionals in various fields. We're talking about how gamers like to push their GPUs to the limit through overclocking.
You're trying to squeeze out every last drop of performance.
Well, NVIDIA has introduced a feature called Error Detection and Replay, or EDR, for the GDDR6X memory interface. This helps to prevent system crashes that can sometimes occur when overclocking memory. If an error is detected, the memory transaction is simply retried until it's successful.
So it's like a safety net for overclockers, making sure those risky performance tweaks don't bring the whole system down.
Precisely. It allows for safer experimentation and helps users to identify the true limits of the memory without causing instability. This is especially valuable for professionals who need to push their hardware to the absolute limit.
That's pretty clever. But before we get too deep into the technical weeds, let's zoom out for a minute. Why should our listeners care about all these advancements? In GPU technology, it seems like a lot of this is geared toward gamers and tech enthusiasts.
That's a great question. And the answer is that GPUs are no longer just about graphics. They're becoming the driving force behind countless innovations that are shaping our world in profound ways.
Okay, I'm intrigued. Give me some examples. How are GPUs impacting fields beyond gaming?
Let's start with medicine. GPUs are accelerating drug discovery by enabling researchers to simulate complex molecular interactions and analyze vast amounts of medical data. This could lead to faster development of new treatments and cures for diseases, potentially saving countless lives.
So potentially saving lives. That's pretty amazing. What other fields are being impacted by GPUs?
In climate science, GPUs are powering simulations that help us to understand and predict the effects of climate change. This allows scientists to make more informed decisions about how to protect our planet. And in the creative industries, from filmmaking to game development to architectural design, GPUs are empowering artists and creators to push the boundaries of their imagination, resulting in more immersive movies, more realistic games, and more innovative buildings.
Wow, the impact is truly far-reaching. I'm starting to see GPUs in a whole new light.
And this is just the beginning. The pace of innovation in GPU technology is relentless, and we can only imagine what the future holds.
Okay, you've got me hooked. What's next on our Ampere adventure?
Let's shift gears a little bit and talk about how Ampere handles video, because it's not just about rendering fancy graphics. The GA102 has a secret weapon for video. It's the 5th generation NVDEC, which stands for NVIDIA Decoder.
Okay, NVIDIA Decoder, what's so special about that? Is that what lets me watch cat videos in 8K?
Well, it could if you had those kinds of cat videos. But seriously though, NVDEC is a hardware-accelerated decoder that takes the burden of video decoding off of the CPU and the graphics engine.
So it's like having a dedicated team just for handling video. That frees up the rest of the system to do other things.
Exactly. This means smoother playback, even for high-resolution video. And it's especially important for newer video formats, like AV1.
AV1, I've heard that name thrown around, but I don't really know what it is.
AV1 is a modern video codec that's designed to be more efficient than older formats like H.264. It can achieve the same quality at lower byte rates, which means smaller file sizes and smoother streaming. But it's also more computationally intensive to decode.
So how does Ampere handle AV1? Doesn't that put more strain on the system?
That's where NVDC really shines. By handling AV1 decoding in hardware, Ampere can play back even 8K HDR AV1 content without breaking a sweat, leaving the CPU free to handle other tasks.
So smoother 8K video without my CPU melting down. I like the sound of that. But it's not just about decoding, right? What about creating video?
You're right, Ampere also excels at encoding, which is the process of compressing video data into a specific format. And for that, it relies on its 7th generation encoder, NVENC.
So NVNC is like the opposite of NVEC. It takes raw video data and makes it into something I can share online.
Exactly. Whether you're a gamer streaming your gameplay or a content creator editing a video, NVENC takes the load off the CPU and graphics engine, ensuring smooth performance and high-quality output.
So even while I'm playing a demanding game, I can stream it at high quality without my system slowing to a crawl. That's pretty impressive.
It is, and it highlights how NVIDIA designed Ampere to be a truly versatile platform, handling everything from gaming to video creation with ease. But let's circle back to the professional side of things for a moment. We talked about how the A40 and A6000 have a ton of memory. But what else makes them so well suited for data centers?
Yeah, those data centers sound like serious business. What kind of special features do those GPUs need?
Well, one key feature is virtualization. Both the A40 and A6000 support virtualization, which means that their resources can be shared among multiple users. This makes them a very cost-effective solution for organizations of all sizes.
So it's like having one really powerful GPU that can be split up and used by multiple people at the same time.
That's a great way to put it. And it's not just about splitting resources. These GPUs are also designed to work together seamlessly with a feature called quadrisync. Multiple A40 or A6000 GPUs can be synchronized to act as one giant GPU.
Hold on, you can sync multiple GPUs together. What would you even need that kind of power for?
Imagine rendering incredibly complex scenes for a movie, or running simulations that require processing massive amounts of data. By linking multiple GPUs together, you can tackle those tasks much faster and more efficiently.
Okay, that's starting to make sense. So we've got virtualization for sharing resources and quadrant sync for combining multiple GPUs into a superpowered system. Anything else that makes these cards stand out in the data center world?
Reliability is absolutely key in data centers, and these GPUs are designed with that in mind. They undergo rigorous testing and certification to ensure that they can operate flawlessly under very demanding conditions.
So they're not going to randomly crash in the middle of processing some critical data.
Exactly. And NVIDIA also provides specialized drivers and software tools, specifically for data center deployments, making it easier for organizations to manage and maintain these GPUs.
You know, we talked about EDR for gamers, but that seems like it would be even more important in a professional setting.
You're absolutely right. That safety net provided by EDR is crucial for professionals who need to push their hardware to the limit without risking instability. It allows for more aggressive tuning and optimization, which can translate into significant performance gains.
That makes a lot of sense. But I'm curious, we've talked a lot about the technical details, but what does all this mean for the average person? How are these advancements in GPU technology going to impact our lives?
That's a great question. And it highlights how GPUs are becoming increasingly pervasive in our lives. Even if we don't realize it, they're no longer just about powering the latest video games. They're driving innovation in countless fields.
Okay, give me some concrete examples. How are GPUs changing the world outside of gaming?
Let's start with medicine. GPUs are being used to accelerate drug discovery, enabling researchers to simulate complex molecular interactions and analyze vast amounts of data. This could lead to faster development of new treatments and cures for diseases, potentially saving countless lives.
So faster and more effective medical research thanks to GPUs. That's pretty amazing. What about other fields?
In climate science, GPUs are powering simulations that help us to understand and predict the effects of climate change. This allows scientists to make more informed decisions about how to protect our planet.
So tackling some of the biggest challenges facing humanity, I'm seeing a pattern here. GPUs are being used to solve some really important problems.
Exactly. And in the creative industries, from filmmaking to game development to architectural design, GPUs are empowering artists and creators to push the boundaries of their imagination.
So more immersive movies, more realistic games, and more innovative buildings. It sounds like GPUs are behind a lot of the things we enjoy and rely on.
They are, and that's just scratching the surface. The applications for GPUs are incredibly diverse and constantly expanding as the technology continues to evolve.
I'm blown away by the sheer scope of it all. It's amazing to think how far GPUs have come and the impact they're having on our world.
And this is just the beginning. The pace of innovation in GPU technology is relentless, and we can only imagine what the future holds.
All right, you've got me on the edge of my seat. What else is there to uncover about Ampere? So we've talked about how Ampere handles gaming and video and even some pretty heavy-duty professional tasks, but I'm curious to dig a little deeper into the professional rendering side of things. What makes the A6000 stand out in that area?
Well, one area where the A6000 really shines is in handling motion blur, which is a notoriously complex effect to render, traditionally rendering motion blur, especially for complex scenes with lots of moving objects. was a very time-consuming process.
Yeah, I can imagine. That trying to realistically blur objects as they're moving through a scene would take a lot of processing power.
Exactly. But the A6000 introduces hardware acceleration, specifically for ray-traced motion blur. It includes a dedicated unit within its RT cores that significantly speeds up the calculations needed to create those smooth, cinematic blurs.
So it's like having a team of blur specialists working behind the scenes to make everything look perfect.
That's a great analogy. This dedicated hardware can result in a 5x speedup compared to previous generation GPUs. When it comes to rendering motion blur, that's a huge time saver for artists and studios.
5 times faster, that's got to be a game changer for professionals who are working on tight deadlines.
Absolutely, it frees up their time and resources to focus on the creative aspects of their work, rather than waiting for renders to finish. And speaking of professional workflows, the A6000 is designed to integrate seamlessly into data center environments.
We've touched on data centers before, but what makes these GPUs so well suited for that kind of setting? It seems like a very different environment than a gaming PC or a workstation.
You're right. Data centers have very unique requirements. NVIDIA has designed the A6000 with those in mind. For example, support for virtualization is crucial in data centers, where resources are often shared among multiple users.
You can have multiple people accessing and using the same GPU at the same time. That sounds pretty efficient.
Exactly. And it's not just about dividing up resources. It's also about combining them with a feature called Quadro Sync. Multiple A6000 GPUs can be synchronized to work together as one, creating a massive visual computing powerhouse.
We talked about Quadro Sync before, but I'm still a little fuzzy on how it actually works. Can you break that down for me?
Sure. Imagine you have a very complex rendering task, like creating a special effects sequence for a movie. With Quadro Sync, you can link multiple A6000 GPUs together, and they will act as a single unified graphics processor. This allows them to share the workload and complete the rendering process much faster.
So it's like having a team of superpowered artists all working together on the same project.
That's a great way to think about it. And it's not just about speed. Quadro Sync also helps to ensure consistent and synchronized output across all the GPUs, which is critical for professional applications.
That makes sense. So you've got virtualization for sharing resources and Quadro Sync for combining them. What other features are important for data center GPUs?
Well, reliability and stability are paramount in data center environments. These systems need to run smoothly 24/7, and any downtime can be very costly. The A6000 is designed with redundancy and error correction features to ensure maximum uptime and prevent data loss.
So these GPUs are built to be workhorses, able to handle a constant stream of demanding tasks without missing a beat.
Precisely. And NVIDIA also provides enterprise-grade support and management tools to help organizations keep their data center GPUs running smoothly.
You know, listening to all of this, it's striking how far GPUs have come. We've gone from simple graphics processors to these incredibly versatile tools that are powering innovation in countless fields.
It is remarkable, isn't it? The pace of development in the GPU space has been incredible. And Ampere is a testament to that progress. It's not just about better graphics, it's about pushing the boundaries of what's possible with computing.
So as we wrap up this deep dive into Ampere, what's the one key takeaway you want our listeners to remember?
I think the biggest takeaway is that Ampere is more than just a GPU architecture. It's a platform for innovation, whether it's enabling breathtaking visuals in games, accelerating scientific breakthroughs, or powering the creative tools of tomorrow. Ampere is shaping the future in ways we're only beginning to understand.
Well said. It's been an incredible journey exploring the depths of this technology. I'm walking away with a whole new appreciation for the power and potential of GPUs.
And that's what these deep dives are all about. Uncovering the hidden complexities of technology that shapes our world and inspiring our listeners to learn more.
So to all our listeners out there, keep exploring, keep learning, and keep diving deep